Each year, nearly 1.8 million tons of Arctic char are harvested, processed, and shipped across continents, enough to fill more than 70,000 refrigerated trucks, each carrying a perishable load that must stay below 2 degrees Celsius from start to finish. It's a system built for precision, operating quietly across the northern edge of the world, where the air is dry, the water is cold, and the margins for error are narrow. In these high-latitude environments, from remote valleys in Iceland to coastal inlets in northern Canada, the fish is raised in conditions that mimic its natural habitat. Water temperatures rarely rise above 6 degrees Celsius. Oxygen levels are carefully maintained, and every stage from hatching to filleting is designed around one principle: keep the fish stress-free and the temperature constant. Arctic char isn't as widely known as salmon, but in many ways, it's better suited to aquaculture. It tolerates colder water, grows steadily over time, and produces a firm, mild-flavored meat that holds its structure during transport. In terms of feed conversion, it ranks among the most efficient farmed fish, requiring just over 1 kilogram of feed to produce 1 kilogram of flesh. That efficiency, paired with cold tolerance and stable genetics, has made it an important species for cold water fisheries looking to reduce their ecological footprint. From the outside, the production facilities appear modest. Rows of circular tanks under metal roofing, sea cages floating just offshore, insulated buildings surrounded by snow. But inside, the systems are anything but simple. Computerized monitors track water chemistry in real time. Laser-guided machines trim fillets to within a millimeter. And every hour, data is collected on growth rates, feed uptake, water flow, and energy use. This is not just about farming a fish. It's about controlling temperature, time, and biology at industrial scale, while keeping the final product consistent enough to meet export standard in more than 40 countries. Most Arctic char is never sold whole. It is vacuum-packed, skin-on, trimmed to customer specification, and shipped by air or sea within hours of processing. It may travel over 5,000 miles before reaching a kitchen, but the internal temperature of the fish, from harvest to delivery, must not vary by more than a few degrees. What looks like a simple fillet in a glass case is the result of years of selective breeding, tightly managed water systems, specialized feed, and an uninterrupted cold chain that stretches across oceans. To see how that's done, we begin at the source, where oxygen-rich spring water flows over gravel beds, and a fertilized egg the size of a pinhead begins a process that now supports a global market worth hundreds of millions of dollars. Arctic char belongs to the genus Salvelinus, a branch of the salmon family known for its adaptability to extreme cold. While salmon migrate to warmer estuaries to spawn and die, Arctic char survives year-round in temperatures that hover just above freezing. It is the only freshwater fish species found as far north as the Canadian Arctic archipelago, and one of the few that continues to feed actively under ice. In biology and behavior, it is built for hard conditions. The regions where Arctic char is most successfully raised share a set of specific environmental features: glacial spring water, stable, sub-zero climates, low population density, and ready access to cold oceans. Northern Canada, Iceland, Greenland, and Norway lead production, each with unique adaptations to local terrain and infrastructure. In Iceland, geothermal energy is used to maintain hatchery conditions year-round. In Greenland, mobile processing units are pulled by sled to lakes that freeze over entirely, where fish are caught through holes in the ice. In Nunavut, indigenous-run fisheries maintain breeding programs adapted to seasonal daylight shifts of 24-hour sun or total darkness. The biological qualities of the fish are closely tied to its commercial value. Arctic char's meat is a pale, pink-orange, somewhere between trout and salmon, with a fine flake and mild flavor. Its fat is well distributed, but not excessive, typically around 5 to 7%, and its skin crisps well under heat without separating from the flesh. These characteristics make it desirable in food service, where consistency and plate presentation matter. Importantly, the fish resists stress better than salmon during handling, making it easier to transport live, with lower mortality during harvest. Historically, Arctic char was consumed in small quantities by indigenous populations and rural northern communities. In the past, it was preserved in barrels packed with ice or salt and eaten smoked or raw. Commercial interest developed slowly, only gaining pace in the late 20th century as cold water aquaculture techniques became more efficient. Today, the majority of global Arctic char production is farmed, not wild-caught, with strict controls on genetics, stocking density, and environmental impact. Even now, the fish is relatively niche in volume when compared to salmon or tilapia, but where it appears, it often commands a premium. Because the production process requires steady cold, isolated infrastructure, and uninterrupted power, Arctic char farming tends to concentrate in regions with robust renewable energy grids, such as hydropower in Norway or geothermal sources in Iceland. These locations allow producers to manage water temperature, flow rates, and oxygenation without depending heavily on fossil fuels. What links all these operations is not size or scale, but climate. Arctic char farming is a system that exists where few others can. It is shaped by latitude, engineered for cold, and powered by a need for control over one of the most sensitive variables in aquaculture: temperature. The next step is where this control begins. In the hatcheries, where broodstock selection, incubation, and early growth determine the entire outcome of production. Production begins in tightly controlled hatcheries, where water temperature, oxygen saturation, and lighting cycles are fine-tuned to replicate a cold, stable river environment. Broodstock are selected based on genetics, prioritizing feed efficiency, resistance to disease, and muscle quality. Each female can produce up to 3,000 eggs, which are fertilized and then incubated in stacked trays with flowing, chilled fresh water. At just 5 degrees, development is slow but deliberate. Embryos hatch after 6 to 8 weeks, absorbing their yolk sacs before beginning to feed. From this stage, temperature becomes the critical factor. Even a rise of Wernbergs can accelerate growth too quickly, compromising muscle density. For the next several months, the fingerlings are graded by size and transferred into juvenile tanks, where they remain until reaching roughly 50 grams, the size of a golf ball. At this point, they are strong enough to be moved to grow-out systems. Once the juveniles reach starboard transfer size, they are moved into grow-out systems, either land-based raceways or offshore sea cages, depending on the region. In both setups, water flow and quality are constantly monitored. In recirculating aquaculture systems, up to 99% of water is reused, filtered through mechanical screens, biofilters, and UV sterilization units. Feeding is automated and precisely scheduled. Feed pellets, rich in marine protein and oil, are released, based on sensor feedback that detects uneaten food. Arctic char converts feed with high efficiency, needing only 1.1 kilograms of input to produce 1 kilogram of growth. Fish are graded by weight at intervals to maintain even development and reduce aggression. Stocking densities remain low, compared to other species, typically under 30 kilograms per cubic meter, minimizing stress. Over the next 12 to 18 months, the fish grows steadily, reaching market weight between 2 and 4 kilograms, a size ideal for filleting and export. Harvesting typically occurs during cooler hours, often at night or early morning, to reduce stress and preserve flesh quality. Fish are guided through a series of channels into a stun-and-kill system, usually using either electrical currents or percussive blows. These methods ensure minimal movement, which limits lactic acid buildup and maintains texture. Once stunned, the fish are immediately bled by cutting the gill arches, then transferred to ice slurry tanks. From stun to chill, the entire process is completed in under 20 minutes. Temperature control is critical at this stage. Water is maintained near 0 degrees Celsius, and insulated containers prevent thermal fluctuation during transport to the processing facility. Rapid cooling not only preserves freshness but also ensures compliance with food safety standards in export markets. In some operations, this step is mobile, with on-site chilling units set up directly at remote cage locations to avoid delays. At the processing plant, speed and temperature control remain essential. Fish arrive in chilled containers and are transferred to automated lines where sorting, filleting, and trimming occur with minimal human contact. Laser scanners map the shape of each fish, guiding high-speed blades to maximize yield. A typical filleting machine processes up to 200 fish per hour, removing pin bones and cutting uniform portions with over 90% efficiency. Fillets are then inspected, rinsed in cold water, and pass through metal detection systems. From there, they move to packaging, vacuum-sealed or skin-packed, depending on market requirements. Modified atmosphere packaging is used for air freight, preserving shelf life by replacing oxygen with a blend of CO2 and nitrogen. Throughout the facility, ambient temperatures are kept below 4 degrees Celsius, with the fillets themselves never exceeding 2 degrees Celsius. Every surface is sanitized on a strict schedule, ensuring compliance with international food safety certifications. Once packed, Arctic char is moved into refrigerated storage areas awaiting dispatch. Time is critical. For air shipments, pallets are loaded into temperature-controlled containers and transferred directly to airports, often within 6 hours of packaging. For land or sea transport, insulated trucks maintain a steady internal temperature between 1 and 2 Celsius. Data loggers track thermal conditions from origin to destination, alerting handlers to any deviation. A typical shipment from coastal Norway to Central Europe travels over 2,000 kilometers in under 48 hours, often passing through customs pre-cleared under export agreements. In North America, char raised in Canada reaches U.S. markets within 36 hours. With limited shelf life, especially for fresh fillets, logistics require near-perfect coordination. Every delay, even of a few degrees or hours, can affect product integrity. Despite these constraints, spoilage rates remain remarkably low, thanks to stringent planning and the stability of cold water species under proper handling. Modern Arctic char farms rely on a mix of mechanical systems and natural energy sources to stabilize production year-round. In land-based facilities, recirculating aquaculture systems use biofilters, foam fractionators, and degassers to purify and reuse up to 99% of water. Sensors track ammonia, pH, and oxygen in real time, adjusting flow rates automatically. In Iceland, geothermal energy is used to warm intake water just enough to keep biological functions active during the darkest winter months. In Norway and Canada, hydroelectric power supplies, chillers, and oxygenation units, reducing dependence on fossil fuels. Solid waste from filtration is dried and repurposed as compost or anaerobic digester feedstock. Fish oil and offcuts are converted into animal feed or pet food ingredients. Some coastal operations install integrated systems, using waste nutrients to grow seaweed or mussels nearby. These closed-loop approaches reduce environmental impact while improving long-term sustainability. Despite its quiet presence in seafood counters, Arctic char has carved out a steady rolling global cuisine. Exports reach over 40 countries, with high demand in Northern Europe, North America, and parts of East Asia. In restaurants, it's often prepared skin-on, pan-seared, or lightly smoked. Chefs favor its fine flake, pale orange color, and balanced fat, milder than salmon, richer than trout. Retail prices vary by region, but sashimi-grade fillets can fetch over $25 per kilogram in urban markets. Norway alone exports millions of dollars worth each year, primarily to Germany, France, and Japan. In Canada, indigenous-led operations supply domestic restaurants and specialty grocers. While total volume remains small compared to salmon or tilapia, Arctic char's controlled production, consistent quality, and cold water origin make it attractive for premium buyers. Many operations now market the fish not only for taste, but also for traceability, energy efficiency, and low environmental footprint. Arctic char production is not driven by volume alone, but by consistency across variables that resist easy control: temperature, oxygen, density, feed uptake, water chemistry. Every batch of fish reflects a series of quiet adjustments. Oxygen valves turned slightly, feed schedules recalibrated, filters cleaned an hour earlier than planned. The system functions because each part holds. One hatchery, one transport delay, one malfunctioning chiller could ripple through the entire chain. Yet across thousands of kilometers and dozens of facilities, the process repeats with minimal loss. The result is a product that arrives trimmed, chilled, and ready, often just 48 hours after leaving water that was colder than ice. What appears as a simple fillet on a plate is the outcome of years of refinement, powered by cold, discipline, and design. At its core, Arctic char farming is a form of temperature management, where biology, engineering, and global logistics operate together in quiet precision.